the project. Me and my future engineers chose collaborating on this project and chose to build a sonar sensor. So I will now introduce you. My name is Sonar Jackson, and I will be the man. And I'm Gloria.
Hi, good day. I'm Antonish, and I'll be explaining what our project is and what our project's objective is. Now, we propose launching our Sonar sensor as a cutting-edge product in the security technology market. This targets customers including security firms, government agencies, and even private owners of high-value aquatic assets. By combining affordability, portability, and high-end sonar technology, our sonar sensor stands out against traditional, bulky, and expensive underwater detection systems. The market opportunity is significant as security threats on land or underwater environments are often overlooked despite increasing risk. Through aggressive markets in an era where security threats are increasing, innovative technologies are crucial to safeguard sensitive facilities, borders, and infrastructures, and high-value assets. This project introduces a specialized sonar sensor designed specifically for security applications. Now, unlike traditional sonar devices used mainly for underwater navigation or marine surveys, this system is tailored to act as an advanced intrusion detection and perimeter monitoring solution, offering real-time detection of unauthorized movement or objects within a secure zone. Now, our project's objective is that our primary objective of this project is to design, prototype, and test the sonar sensor optimized for security environments capable of detecting intrusions in restricted underwater or semi-aquatic zones. It can also be able to detect intrusions on land as well. It helps to provide real-time data transmission to a central security station, and it is operating under various environmental conditions such as low visibility and noise interference. It's also being compact, affordability, and easy to deploy. And that is our project's objective and what our project is.
Good day everyone, my name is Austin, and I will be speaking to you about why we chose a sonar sensor for our project. The reason we chose a sonar sensor for our project is because it provides a reliable and cost-effective way to measure distance using sound waves. In an age where threats to infrastructure, assets, and personnel are becoming increasingly complex, the need for innovative, reliable, and cost-effective has never been greater. Sonar sensors are particularly useful in environments where it is inferred our laser may not perform well, such as in dusty, dark, or smoky conditions. Additionally, sonar sensors are easy to integrate with microcontrollers like our Arduino, making them ideal.
My name is Sonar Jackson, and I will be presenting on advantages of a sonar sensor. A sonar sensor has various advantages, one being that it is very cost effective compared to the camera system that we know that is commonly used in society right now. This sonar sensor is mainly used in restricted areas. For instance, someone who has a warehouse and they know people are not supposed to be in there. It has two sensors, a motion sensor and it has a distance measurement. So a device that measures distance. Well, some will say the camera is better because you can see, but take into consideration if someone enters your building and you have a camera, yes, you can see that they entered your building, but how will you be notified that someone is in your building? See, this is why we developed the sonar sensor, so that when someone enters the building, like if someone is in your building, yes, the camera will detect them, but the sonar sensor will send a notification to your phone or whichever device you set it up to say, hey, someone is in this building, let's call the police, or you have a faster reaction time other than the camera. You will, because most people that has cameras really sit and go through the footage, but this sonar sensor, you can detect if someone is there. No. Nextly, it can you work together with the camera system also. So if someone who has a camera, it can be merged. So there will be camera and it will be a sonar sensor, double the safety. So you can be notified when someone is in your building or in a restricted land or in a restricted area and they have no case being there. The camera will sense, you will have video evidence, plus you will have motion sensor, and they would get it. It has distance measurement. You can sense where they are. So this sonar sensor is very, very important, and I think it will take society to the next level. Another advantage that this sonar sensor has is that it can operate in very dark with no light. It can operate with no light. So even if a building has no light or outside a yard has no light, it can still pick up motion. It can still pick up distance without light. So that is very necessary, since sometimes the camera might can't catch certain things in the dark, and it can't catch around. Like say there is like a building in front of you or a wall in front of you, a camera can't catch the person, but the sonar sensor will pick that up because it detects motion. It just doesn't detect what it sees. It can sense motion, and that will be very helpful in various cases.
So for our project, what we used was this camera casing to be able to house our components. We used ultrasonic sensor, which is a HCSR4 sensor. We used a PR sensor, which is our HCSR501 sensor. And we use a LED also with a buzzer, which is inside, and which is connected by the insulation that insulates our wires, and our box, which houses our microcontroller, which is the Arduino Uno R3, and the power supply, which is 9 volts, which is connected by this. So how would you mount this to any surface or material you want to use? I will show you using my desk as an example.
So using my desk for the example, you usually drill a hole through the wall or required surface, and you push your wires and the insulation through, and then you drill your holes to connect. You also drill your box onto the wall, so it'd be like right there next to it.
Okay, so our defines. These state which pin goes to which digital pin. So for our trig pin, it's digital pin 9, echo pin, digital pin 10, and so on. Our last motion time. This stores when last motion was detected, and this is a delay, constant unsigned motion time. This is the delay for the alarm. Okay, now we're going into the ultrasonic sensor, which we're going to state which pin goes to our output and which pin goes to our input. Also our serial begin.
this states for our communication between our laptop to be able to read on the serial monitor and the microcontroller. Also for the PR pin and so on, as you can see. Float measure distance. Okay, now this starts the beginning of the ultrasonic sensor. So it hasn't started as yet until we send a pulse, which is for 10 microseconds, out through the high, and then it receives through the low. And then we're going to divide the distance, which is the speed sound travels, by the distance it's going. So it's going to travel from the ultrasonic sensor to the object and then back. So we divide it by 2. Now for PR sensor, this states when motion detected. It reads the PR sensor, so when motion is detected, and measures as distance. And we printing. This is for our serial monitor to be able to see which distance we're going to see in centimeters, and if anything is going to be detected or not. Now, if motion is detected, then it must be within 50 centimeters for the alarm to go off. So this is for our buzzer and alarm. So this is for our alarm system right here. And we set it to a delay of 500 milliseconds between the high and low pulses. And that's basically our code. Very simple. You can understand. Thank you for your time.